Hi, I'd just like to reiterate how to adjust the hysteresis widths with the power supply. Again, like I said last time, you can load in the INI file, right, to get your power supply widths, right, but you have to adjust these. So I'm just going to show you how to do that. So let's say I'm at plus or minus 5. I go to the oscilloscope and I'm at 0.41 and 0.39. And so let's say I want to go bring that down to point 0.2 on either side, right? So I can adjust my power supplies like this, like set that to 3 and set that to -3, and you just look at the equation and it shows you how that works, right? And then I measure it and I'm like at 0.24 and 0.21. So I'm going to change what I want just to make an easier video and say that I want them both to be at 0.25, right? So this one's too low, right? So what I can do is come back here and increase the power supply. Let's try that, right? And so now I'm at 0.23. I need to come up a little bit more. I might overshoot it. That's 0.246, so that rounds up to 0.25. And that's 0.24, so that doesn't quite round up. So I'll just make that a little more negative. And 0.25, made it a little too much, too high. So I think I'll just leave it where it is, 3 and 3.4. And so, I guess I was just measuring it sloppily, 0.25, and it rounds up to plus 0.25. So you want to do that before you start taking your data. Some groups are going to be, you want it plus or minus 0.3 hysteresis width, and some will be plus or minus 0.2. But you can't get it exact, and so within 10% should be fine, right? That way, hopefully, then the only thing varying will be the variance in how fast any particular op amp is. But yeah, there will be a transition time, because if the power supply, if the voltage that it's going to, the high and the low, are different, it can take less or more time to get there, rise and fall time, which could affect the full width half maximum. I don't really know. And so that's what we're here to find out. So we're just going to keep the hysteresis width the same and let the power supplies change a little bit. But with a smaller power supply, with a smaller hysteresis, right, I should be able to, when I come back to the here, making sure I go to 50, right, and you want to turn off that, and okay, so you can see that it's working. But now that my hysteresis width is smaller, right, I should be able to have a smaller scale factor. Oops. And still see it work. Maybe 500 was still too small. That's okay. Oops. Alright, it's almost working there. It's a little bit slow. So I might want to zoom out a little bit more. Notice the RMS had gone down, and that's because I'm kind of too zoomed out. All right. So like I said, I can zoom in and get a good RMS value, right? And then zoom out a little bit for the data. But yeah, it's working at a much smaller frequency, right? And the other thing too is that's why the amplitudes, now let's add the forcing function, right? If I make this to 400, which is pretty much, or no, let's make it 450, right? That is like the hysteresis width. We come back to the oscilloscope, there's our pattern, and then look at the spectrum analyzer. I would expect to see that maybe there is some overdriving of it. Yeah. So there's the fundamental, there's the third harmonic, and then the fifth. So that's more than likely I'm overdriving it. Where 200, where before, when the hysteresis width was wider, that wasn't a problem. But on the other hand, it should be more sensitive, where maybe now I can see 50 millivolts peak to peak, right? Let's see what the spectrum analyzer. Now I'm just going to the spectrum analyzer each time. Rather than running the Python. Well, it doesn't, looks like that's just not quite sensitive enough, or it's not big enough. And so what you can do is use the spectrum analyzer, right, to find your regime where it's working. And this looks like it's actually starting to work at that input. Okay, so 100 millivolts peak to peak, right? It's amplitude of 50. All right, so that's like the bare end. So in this here, I'm giving some suggestions, but try to find a different amplitude for each person. Okay, 50 didn't seem to work very well, so you can, and 400, right? We're more here, okay? All right, and of course your frequencies will be different, but that should be it, and that's maybe the final video of